talk about slope at a point on a given polar graph. So what you see in front of us is an equation, r is equal to 1 minus cosine theta. We have that mapped out on the graph here below. So this is actually on an xy axis. So there's the x-axis, got the y-axis, okay? And then our polar graph we know would be circular in nature. And this is kind of how it maps out with, again, our 5-number summary, okay? So the idea here is today we want to find out the slope of the tangent line, okay? So we're trying to find the tangent line at any point r theta. So this actually poses kind of a problem, okay? So the problem is that if we take the derivative, okay, we're going to get sine of theta, okay? And once we get sine of theta, that is the rate of change with an r with respect to theta. So it's the radius changing with respect to how the theta changes. So you can think about this as how far away from the polar axis or from the origin it's getting, okay? It's not really giving us a rate of change in terms of x and y. So as theta increases, r changes, okay? And this has, as we look back at this graph here, the radius, it's getting further away, further away, further away from there, okay? The radius is getting bigger, 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 and then it changes. The radius gets smaller, it's getting closer and closer to that pole, okay? Closer, 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 and it's going down here. So if we try to look at this in terms of the 4 quadrants, okay, it's not really that helpful for finding our rate of change is in terms of a line, okay? And if we look at the 4 quadrants, we notice the radius is increasing in quadrant 1, increasing in quadrant 2, and then decreasing and decreasing. So it gives us information, but it's more of how the radius is changing, not what we're looking for, rise over run. So what we need to do is we need to find dy dx, okay? We're going to do that by looking back at the equation again. So the equation we're given 1 minus cosine theta. And what we can do is we can break it down to using x and y that we know, the relationships we know. So the first relationship we know is that x is equal to r cosine theta. Okay, we actually substitute the r in and we can get an expression for x in terms of theta over here on the right-hand side. Okay? Then we can take the derivative of that using the product rule. Okay, and we can kind of clean it up a little bit, and we get dx d theta is equal to negative sine theta plus 2 sine theta cosine theta. Okay, we repeat that process for y. If we have y, we substitute r in, so here's your r again. Okay, substitute in for sine. Use the product rule, okay, and we get a dy d theta is equal to cosine theta minus cosine squared theta plus sine squared theta. We get excited because this looks like 1, but we got to remember there's a negative in front, so we can't do that. So now if we combine this equation up here together with this equation here, okay, and do a division, okay, we know that dy dx is equal to dy d theta over dx d theta, okay? And we can combine those two together into a ratio that looks like this, okay? Now all we have to do is we're going to pick a value. So if I go back to the top, if I pick a value, let's say I want to talk about what's happening here, okay, at pi over 2, okay? I can pick a value of pi over 2, go back down here, pick a value of pi over 2, just substitute it into that dy dx equation, okay, and we get negative 1 as that rate of change. Now remember that rate of change is rise or run, okay, or that process, okay? Then we need to find a point, so we're going to go back to our x equals equations and our y equal equation, find a point, so our point, so the slope is negative 1 at the point 0, 1. We can come up with an equation of a line with that information. So we get point slope form. We can reduce that to y equals mx plus b. Okay, now the beautiful thing behind this is we changed everything into rectangular. And now we're going to go back and we're going to substitute our y, our x in, and now we can convert it. Okay, so we slide this to the other side, factor out, and we come up with our final answer, which is r, okay, in terms of theta, okay? So you're like, it's hard for us to see that because we're so used to rectangular coordinates. So if I look at a graph, okay, that I have here, okay, this is the function we have. If I take 1 divided by r is equal to 1 divided by cosine of theta Okay, and then we had times sine theta. It was plus sine theta. Okay, we find that we came up with our tangent line at that point right there. Okay, and that's the tangent line, but now in terms. Now I can still express it as, y is equal to negative x plus 1, and that's going to give me the same thing. But I wanted to have it in terms of r and theta to stay in my polar form. So that's how we get our equation of a tangent line.